Okay, we are going to talk about some special systems, and we will talk about how to graph these special systems. Now, when I'm talking about a special system, I'm basically saying you can have graphs of two equations that do not intersect at all, or the two lines may be the exact same line. So how can we come up with the solutions for these special systems? Let's go ahead and take a look at our first example here. Now, this example, you have again two equations in your system, x plus 2y equals 4, and 2x plus 4y equals 12. Now again, we will go ahead and find 2 points on the first equation and 2 points on the second one, so we can go ahead and graph this system. Again, I'm going to use my x and y intercepts here as my 2 points. So to find the x-intercept, you make your y 0, which makes this term disappear, and you end up with x equals 4. To find the y-intercept, we make x 0, which will give you 2y equals 4. Dividing by 2 on both sides will lead you to y equals 4 over 2, which is the same thing as 2. Okay, then you have our second equation, 2x plus 4y equals 12. Again, we'll go ahead and find our x and y intercepts. So if I take my y to be 0, this term disappears. You end up with 2x equals 12, which will give you 12 over 2, or x equals 6. That's your x-intercept. To find your y-intercept, we make our x 0, so that term disappears. You end up with 4y equals 12, so you have y equals 12 over 4, or y equals 3. Okay, so go ahead and find your x and y intercepts as your 2 points. And now, using these 2 points, let's go ahead and graph this system. So we have our axis plane here, and let's go ahead and graph our first line. Your points are 4, 0, which will be the point right here, and the other one is 0, 2, which will be this point, and let's draw a line through them. Again, don't forget to name your line. So this one was x plus 2y equals 4. Now we can go ahead and graph the other one. Your points were 6, 0, so that will be 6 will be right here. Okay. The other one was 0, 3, and that point will be right here. 0, 3. So when we graph these, join these 2 points, and this one was 2x plus 4y equals 12. And you will notice that these 2 lines are parallel lines, and as we all know, parallel lines do not intersect, so you're not going to have a point of intersection. These lines are. So what happens with the solution set to such a line? If you don't have any point of intersection, which means that there is no one solution that will satisfy both your equations. This leads us to conclude that the system of equations here has no solution. Okay, so we have So when you're trying to represent that a system has no solution, what we will use is the empty set symbol. We'll say that the solution set of this system is an empty set, and we will go ahead and use the symbol for our empty set. So anytime you end up with a system of equations where the two lines are parallel to one another, you're not going to have a solution to that system, and that system will have a null set or an empty set. Now, we talked about another type of a special system. We said that you can have either a system where the two lines do not intersect at all, or there might be a system where the lines are the exact same line. Let's see what kind of a system this one is. Your equations are 2x minus y equals 4, and the other equation is 4x equals 2y plus 8. Now you can see this equation is not in the standard form. You have 4x on one side and 2y on the other. So the first thing we will do is go ahead and write this in the standard form. So that will be 4x, taking your 2y over to this side, we subtract 2y, and that will give you 4x minus 2y equals 8. Okay, so all we did was take the 2y and subtract it on both sides and move it over to the other side. Okay, now that we have both our equations in the standard form, let's go ahead and find our 2 points that we need to graph this line. Okay, so again, I will still use the x and y intercepts to help me out here. So if I make my y 0, I end up with 2x equals 4, or x equals 4 over 2, which is the same thing as 2. And then making our x value 0 will give us y equals, negative y equals 4. Taking the negative over will give you y equals negative 4. So we have our 2 points from the first line. Let's go ahead and find our x and y intercepts on the second line. So again, making y 0 will give you 4x equals 8. Divide by 4, that will give you x equals 2. And finding our y-intercept, make your x 0, negative 2y equals 8, divide by negative 2, which will give you y equals negative 4. So if you will notice, both our x and y intercepts for both our lines are the exact same points. So if you try to graph this equation, or actually graph both of these equations, this is what your line will look like. You have 2, 0, and 0, negative 4 as your x and y intercepts for both the lines. And that tells me that both of these equations have the exact same line for their graphs. So this line represents the 2x minus y equals 4, and it represents 4x minus 2y equals 8. Okay? So what happens in this case when you're talking about the system solution set here? Now, we said each point on the line was a solution for the given line. So if both the lines are overlapping, or you can think of these lines being one on top of the other, if both the lines are overlapping, that means that all their points coincide. All of them have the common point. So every point on this line is going to be a solution for both our equations. And since a line has infinite number of points, that tells us this system has infinite number of solutions. Okay, so let's go ahead and write that down. So as I said, every point on the line is a solution set, is a solution of the system, and your solution set contains an infinite number of points. Or you can think of this as infinite number of ordered pairs. So when you're trying to write this as a solution set, we use the set builder notation. And we will write this in the form. Now x and y basically represents the ordered pairs that will satisfy your solution, and since both the equations have the exact same line, you can write any one of the equations here in your solution set. So basically what this notation here tells you is that all the solutions of this equation, 2x minus y equals 4, in the form of ordered pairs will satisfy our system of equations. Now, there's another thing I want to show you before we move on. Looking back at our two equations here, you had 2x minus y equals 4, okay? And then in the standard form, our second equation was 4x minus 2y equals 8. Now, if you just take a look at this, if I take my first equation and I multiply the whole equation by 2, okay, what will we end up with? If I take that, you will end up with 4x minus 2y equals 8, and you will see this is the exact same thing as what our second equation is. So basically our first equation is twice the value of our second equation, and that's the reason why both the equations had the exact same line as their solution. Okay, let's do a quick recap of the different types of solutions that we can come across when we are talking about a system of equations here. So the first example, set of examples that we saw, we had where the graphs were intersecting at exactly one point, and that point gave us exactly one ordered pair as the solution of our system. When you have any system of that form, we call the system a consistent system, and the equations are called independent equations. Okay, so that was the first set of examples we saw. Then we had graphs of parallel lines where we said that there is no solution to such a set, and we called it an empty set. And in this case, the system where the two lines are parallel is called an inconsistent system. Okay, so when the two lines intersect at one point, it's a consistent system. When the two lines are parallel, we call it an inconsistent system. And then we had a third type of solution, which was where the lines were the exact same line, and you had an infinite number of solutions, and in this case we call the equations as dependent. So these are the different types of systems, solutions that you can come across.